Hello and welcome back to Equity Tutors. Today's lesson we are going to be building on what we worked on last week on glucose regulation. So as we discussed last week, glucose is really important for the body and it's important to keep the levels of glucose in the correct range within the blood. So in order to do this, we have a couple of mechanisms that are used, and this is mainly controlled through the pancreas. So if this all sounds very foreign to you, please do go back and listen to last week's episode so that you can really understand those basics before you go on to learn a bit more today. So I'll quickly recap what we learned last week. So we learned a bit about the structure of the pancreas, specifically the islets of Langerhans, and we learned about the alpha and beta cells. So we know that the alpha cells secrete glucagon and the beta cells secrete insulin, and glucagon is released when the blood sugar is low, and this causes a release of stores that allow the blood sugar to increase back to the normal range, and insulin is released by the beta cells when there is too much glucose in the blood, so this is used to reduce the level of glucose in the blood. So we spoke about last time how the insulin affects muscle cells, fat cells and the liver, and that glucagon acts in the liver to cause the release of glucose. So we're going to now today talk a bit more about how these hormones work on the liver and the effect that they have, and then we are going to talk about diabetes and how this is a dysfunction of the glucose regulation within the body. So let's start off by talking about the liver and how glucose regulation is controlled in the liver. So as we spoke about last time, the liver plays a really important role in regulating blood sugar levels, because this is the site where there is the conversion of glycogen to glucose and glucose to glycogen. So if we think about how this works, with insulin we want the blood sugar to reduce, so that means that the glucose in the blood is being stored as glycogen within the liver, and if there is a high amount of glucagon, then that means that the blood sugar is too low, and that means that within the liver the glycogen will be converted into glucose, which will then be released into the blood. So it's really important that you know what the insulin and the glucagon do before we go on to understand these different types of conversions that go on. The first thing that we're going to talk about is glycogenesis, and we can break this word up into two halves. So there's glyco and there's genesis. So genesis means the formation or synthesis of something, and glyco is for glycogen. So this means glycogenesis is the formation of glycogen. So that means that glucose molecules are being converted into glycogen, which is then stored. So if we think back to last lesson, this means that there is glucose that is needing to be removed from the blood, which means this happens by insulin. So insulin triggers this glycogenesis, and this removes glucose from the bloodstream and it converts them into glycogen stores within the liver. So glycogen is a very compact carbohydrate store, so it's a way that we can store the energy without having this high blood sugar. So then we have another type of conversion which is called glycogenolysis. So again, we've got glyco there, so that means it's involving glycogen, and this word has lysis in it, so that means that something is being broken down. So this word means glycogen is being broken down. So glycogen is being broken down to produce glucose molecules. So if glucose is being produced, that means that the blood sugar would have been low, which means this process is mediated by glucagon. So there is glucagon in the blood because there is a low level of glucose, so that then triggers the liver to undergo glycogenolysis, breaking down the glycogen stores into glucose, which is then released into the blood. So the outcome of this is that the glucose concentration within the blood goes up back into the normal range. So then we have a final type of conversion, which is called gluconeogenesis. So as you can see, this has similar parts to the previous two forms of conversion, but there are some slight differences. So it has genesis in it, which means it's forming something. And then it says gluconeogenesis. So the neo means new, and the gluco is referring to glucose. So this is where we have glucose produced from non-carbohydrate molecules. So that's what the neo part means. We have glucagon triggers this as well. So it means that it's done when there is low blood sugar. So glucagon activates an enzyme within the liver that can convert other molecules that aren't carbohydrates, so things like amino acids and fatty acids, into glucose molecules. And then this causes an increase in blood glucose back into the normal range. But this happens when there aren't any glycogen stores available. So normally we would undergo glycogenolysis, but occasionally if we don't have enough stores to bring up the blood glucose to the normal range, then the liver will undergo gluconeogenesis, where we're not converting glycogen into glucose, but we're actually converting non-carbohydrate molecules into glucose. So this is more of a backup. So this is happening when there isn't any glycogen stores available to be used. So I'm now just going to do a bit of background on the way that glucose is regulated so that we really get this idea in our head. So as we've spoken about just now, there are two ways of getting glucose into the blood from storage molecules. So we can either have glycogenolysis, which is what is triggered by glucagon, which causes the breakdown of glycogen stores into glucose molecules. We can also have gluconeogenesis, which is where glucagon triggers non-carbohydrate molecules to be broken down into glucose. And then we can also get it from absorption of food that we eat that contains carbohydrates. So some meals that we eat might be much more carbohydrate rich, and therefore we can have varying levels of glucose in our blood at different times. So that's where the insulin and glucagon are really important to help manage this concentration of glucose. So after we've eaten a very carbohydrate rich meal, we will have a large amount of insulin released to make sure that those blood glucose levels don't go too high. Again, if we haven't eaten for a long time, then if the blood glucose levels get too low, then glucagon will be released, and this will allow for the release of glucose from storage molecules either via glycogenolysis or through gluconeogenesis. So whenever you're answering a question about blood glucose regulation, you really need to link it back to either insulin or glucagon, and you want to talk about whether glucose is being released into the blood or removed from the blood, and whether that's happening via glycogenolysis, or gluconeogenesis. So I know these words are really confusing and they all sound very similar, but break them down like I did earlier and then it will be easy to remember. Okay, so now that we know how blood glucose is regulated, we can now go on to talk about what happens when this regulation is not controlled the way it should be. I'm sure everyone has heard of diabetes, and you probably know someone who suffers from this disease. So diabetes is a condition where the control of blood glucose is not working properly. So the homeostatic control has either failed completely or is deteriorating. And the insulin is not working properly, which allows the glucose concentration within the blood to rise uncontrollably. So there are two different types of diabetes. There is type 1 and type 2, and I am now going to go into exactly what each of those is. So a key thing to know is that one of the main signs of diabetes is having glucose in the urine, and this is because there is really high glucose concentration in the blood, which isn't being removed as it should be. So then the kidneys are unable to filter all of this glucose out of the blood, so it can appear in the urine. And because there is more glucose in the urine, the kidneys will produce more urine, and this will cause the person suffering from diabetes to become dehydrated. So this is often how people find out that they are suffering from diabetes, is because they are having an increased frequency of urination, and then if you test their urine, you can often find glucose in their urine. So let's first talk about type 1 diabetes, and it's really important that you can say about the differences and similarities of both type 1 and type 2 diabetes for your exams. So type 1 diabetes is where the pancreas does not produce sufficient insulin to control the blood glucose levels. So this normally starts in childhood, and sometimes this can be called early onset diabetes. So type 1 diabetes is caused by the breakdown of the beta cells within the islets of Langerhans within the pancreas. So as we learned about in last lesson, the beta cells are what produces the insulin. So if these beta cells are destroyed, then the beta cells are unable to secrete the insulin, which helps control the blood sugar levels. So this is normally an autoimmune response. So the body's immune system incorrectly attacks the beta cells within the pancreas. So your immune system thinks that they are not meant to be there, and it attacks them, but actually they should be. So as we spoke about last time, maintaining the correct level of blood glucose is really important to have normal organ function. And in people with type 1 diabetes, if they haven't had this controlled properly, then they can reach really high levels of glucose in their blood, and that can cause damage to their organs. So it's really important that they get this disorder managed very well. So now that we've understood why type 1 diabetes exists, we now can talk about how it can be managed and treated. So people that are suffering from type 1 diabetes will undergo regular blood tests, which will test their blood glucose levels, and then they will normally inject insulin to help control the levels to get them back into the normal range. And this can be done either periodically by taking blood every so often after eating meals, or now there are some newer devices that can monitor your blood sugar as you go about your day. So there are devices that you can wear that constantly monitor your blood sugar, and that some of them also have pumps which can release the insulin into your blood as it's needed, rather than someone having to test their blood and then do an injection. The other thing that is important if people are suffering from diabetes is that they have an appropriate diet. So they should try and reduce the amount of processed foods and increase the amount of fruit and vegetables they eat. So basically they should be doing what we all should be doing, but they do need to pay a bit of attention to their diet so they're not eating lots of sugary and high carbohydrate foods, which could cause a massive spike in their blood sugar levels. So there are two different types of insulin that can be used. So there is fast acting and slow acting, and these are just different versions of insulin which either can last over a long time, or they can act very quickly and then their action stops very quickly as well. So the good news is that now if people are controlling their diabetes very well, that they can live a very normal and fulfilling life, and it shouldn't affect their everyday ability to do things. So now that we've spoken about type 1 diabetes, we can now speak about type 2 diabetes. So type 2 diabetes is more common than type 1, and it normally develops in older people, so normally people over the age of 40. However, now as our diets have changed, there is an increasing number of younger people suffering from type 2 diabetes. So the difference with type 1 and type 2 diabetes is the islets of Langerhans, so the beta cells. So in type 1 diabetes, we said that the beta cells are destroyed, but in type 2 diabetes, the pancreas does still produce insulin, but the receptors on the cells in our body are reduced or don't respond as well to it as before. So insulin is still being released from the pancreas, but the liver has become resistant to it and doesn't respond to it as it should anymore. So that means that the blood glucose levels remain high because glucose isn't being removed from the blood. So the result is the same as in type 1 diabetes. It results in high levels of blood glucose. And this loop causes the beta cells to produce more insulin because they're detecting that the levels are high or in the blood. So the beta cells are detecting this high glucose concentration in the blood, so they're producing more insulin, which then actually ends up damaging them in the long run. So they're just pumping out insulin, but the insulin isn't having the effect it should. So for people with early stage type 2 diabetes, they can actually manage this by controlling the amount of sugar and fat they have in their diet and by exercising regularly. So they need to eat foods that aren't rapidly broken down into glucose, and that should stop any really high spikes in blood sugar. And one of the main risk factors for developing type 2 diabetes is obesity. So people who are obese are likely eating high carbohydrate foods, and this can cause the overproduction of insulin, which over time basically makes the body resistant to the insulin. So a really key thing to remember here is that in people suffering with type 2 diabetes, they are producing insulin, but it's not having an effect on the cells in the body. So this can't be treated very easily with injection of insulin because that isn't the cause of the disease. There is insulin in their body, but the insulin isn't having the effect it should do. So in type 1 diabetes, there is no insulin being produced, so we can counteract that by injecting insulin to have the effect by bringing the blood sugar levels down. But with type 2, what we actually need to do is control the blood sugar levels from the outside, so by having a low carbohydrate diet, so that we don't get these spikes in blood sugar, because even if we are given insulin, they probably won't have much response to it because their cells have become resistant to the insulin. So another key thing about diabetes is that if people are not controlling their diabetes properly, they can get very high blood pressure, and that is because if there's more glucose in the blood, then the water potential of the blood is lower, which means more water will go into the blood from the tissues via osmosis, and that means that there's more volume within the blood, which causes the blood pressure to increase. So that's often a sign of diabetes, and it can be used to see if your diabetes is being managed properly. So the final thing that I want to talk about today is adrenaline and how adrenaline can also affect blood glucose levels. So adrenaline is a hormone that is released from the adrenal glands, and it can cause an increase in blood glucose concentration. So the adrenal glands are glands that sit on top of your kidneys, and adrenaline is released when there is a need for energy to be released very quickly. So it's not part of your normal everyday blood glucose regulation like glucagon and insulin, but it does work in a similar way to glucagon by causing an increase in blood glucose levels. So we're just going to briefly talk about how it works. It's very similar to glucagon. So it binds to a receptor that is different to the receptor that glucagon binds to, but it is also on the surface of the liver cells. So the process is very similar to that of glucagon, and it also works via the second messenger model. So as we know from last week, the second messenger model is how glucagon brings about its effects, and what happens is that adrenaline binds to a receptor on the membrane of the liver cells, and this is a different receptor to that glucagon binds to. So when the adrenaline binds, then it causes adenylate cyclase to become activated. This can then allow the conversion of ATP to cyclic AMP, which the cyclic AMP is the second messenger. The cyclic AMP binds to the protein kinase A, which then is activated. This can then activate phosphorylase kinase enzymes, and these can then activate glycogen phosphorylase enzymes, which go on to catalyze the breakdown of glycogen into glucose. So remember, this process is called glycogenolysis, and this results in an increase in blood glucose levels. So the effects of adrenaline and glucagon are the same, but adrenaline also stimulates the breakdown of glycogen, which is stored within the muscles during exercise. And this allows glucose that is produced from this breakdown to be used by the muscles for respiration. So adrenaline is really used more short term, and especially when we are exercising or if we need to escape a situation. So if you're fight or flight, then the fight will allow you to have adrenaline release, which will cause this breakdown of stores to allow glucose to be released, and that allows us to have the energy to undergo respiration in the muscles so that we can either fight or run away. So adrenaline is also very important for blood glucose regulation, but it's not one of the everyday things that is used. It is normally glucagon and insulin that regulate our blood sugar. Okay, so that's the end of today's lesson. So we recapped what glucagon and insulin do. We talked about the different conversion processes that are undergone in the liver, so glycogenesis, glycogenolysis, and gluconeogenesis. We then spoke about the dysregulation of blood glucose levels in diabetes, and we spoke about the differences between type 1 and type 2 diabetes, and then we've briefly gone over the action of adrenaline in regulating blood sugars as well. I know there is a lot of content today and in last week's lesson, so do keep reviewing it until it's really solidified in your mind.
Thank you so much for listening. Remember, you can access additional content on our Patreon page by searching for Equity Tutors, where we have a second 30-minute lesson every week, plus monthly bonus content. You can also find us on most social media platforms. We will keep you updated on new content, and you can find us there by searching for Equity Tutors UK. Please like, share, subscribe and comment wherever you are listening, and if you're enjoying, please leave a review. Bye!
Bye!